5.8 modeling quadratic equations. So when we're looking here, we're going to think of two forms of that we see in quadratics. First one, vertex form, which again is y is equal to a times x minus h squared plus k. The other form we're going to look at is intercept form. Okay, so intercept form is y equals a times x minus p times x minus q, where p and q are representing those x-intercepts or our roots or solutions to a quadratic. Okay, so vertex form, we're going to be getting a vertex and another point. Intercept, you're going to be given two x-intercepts and another point. Now our goal for modeling quadratics is, given that information, come up with the equation. So first one, write a quadratic function in vertex form with the given information. Vertex form again, y is equal to a times x minus h squared plus k. So if we are given the vertex, if you remember, the vertex is hk. So we're going to take those values, plug them in for h and k. So when we do that, we get y is equal to a times x minus negative 2 squared plus 1. Simplifying the inside the parentheses there then, x plus 2 squared plus 1. So then from there, we have another value. We have x and y. Okay, we've used the vertex. We just need to use that other point. So we're going to use that for x and y. When we do that, all we're left with is a and numbers. So since that is the case, we can solve for a. So we got negative 1 is equal to a times 3 squared plus 1. So then simplifying, negative 1 is equal to 9a plus 1. Subtracting 1 over, we get negative 2 is equal to 9a. Divide by that 9, we get a is equal to negative 2 ninths. So in our last step to do this then is we take that a value and plug it into a. So our final answer then, y is equal to negative 2 ninths times x plus 2 squared plus 1. So again, our goal on these is to write a quadratic function in the given form. So in this one, it was vertex form. So if I have you write something in vertex form, we need the vertex and another point. All right, we'll do another example of that. So vertex form, again, y is equal to a times x minus h squared plus k. Here's h, there's k. So y is equal to a times x minus negative 2, so x plus 2 squared minus 1. Plugging in that x and y value, we get 4 is equal to a times 0 plus 2 squared minus 1, or 4 is equal to a times 2 squared minus 1, which will give us 4 is equal to 4a minus 1. Adding that 1 over then, we get 5 is equal to 4a. Finally, divide by that 4. A is equal to 5/4. And again, we're going to take that value and plug it in to a. So our answer will be y is equal to 5/4 times that x plus 2 squared minus 1. All right, that was vertex form. Let's move on to intercept form. Again, intercept form, y is equal to a times x minus p times x minus q. Now, p and q are representing our roots, okay, or the x-coordinate of our x-intercepts. So, just like we did before, plug those values in. And we're going to get y is equal to a times x minus 1 times x minus 4. Okay, we took care of the x-intercepts. Now we got to use that other point. Same idea. We're going to use that for x and y. So negative 6 is equal to a times 2 minus 1 times 2 minus 4. So negative 6 is equal to a times 1 times negative 2. So negative 6 is equal to negative 2a. When I multiply that out, divide by that negative 2, we get a is equal to 3. And again, taking that last step, plugging that a value in. So here we're going to get y is equal to 3 times x minus 1 times x minus 4. There is our quadratic in intercept form. All right, one more, and then we'll actually do a quadratic regression problem. So taking that value, y is equal to a times x minus p. So x minus negative 2, so plus 2, then x minus 3. Plugging in our xy value, negative 4 is equal to a times 2 minus 2 plus 2, then 2 minus 3. So negative 4 is equal to a times 4 times negative 1, or negative 4 equals negative 4 to a. Therefore, dividing by that negative 4, we get a is equal to 1. So y is equal to 1 times x plus 2 times x minus 3. All right, so that's modeling. The big thing here, I'm giving you specific parts of a parabola, and you are coming up with the equation. If it's in intercept form, you're going to be given 2 intercepts and another point. If it is a vertex form, you'll be given the vertex and another point. All it is just plugging in those points that you know of. Okay, so like the vertex form, we know the vertex, so we plug it into H and K. Intercepts, we plug intercepts into P and Q. All right, so one last quick question. Regression, quadratic regression. Now, we're going to get a real-life situation. Anytime you catapult or throw or launch, okay, all those real-life situations represent a quadratic, okay? So like in this case, we're talking about catapults. They're going to send off a pumpkin, okay? This is a competition in Morton, Illinois, where people can compete to see whose catapult will send pumpkins the furthest. One catapult launches pumpkins from 25 feet above the ground at a speed of 125 feet per second. Table shows a horizontal distance in feet the pumpkins travel when launched at different angles. Use a graphing calculator to find the best fitting quadratic model for the data. Okay, so this data, they're sending these pumpkins off at different angles. So at 20 degrees, the pumpkin went 372, 30 degrees, 462, 40, 509, so on and so forth. Okay, so anytime we did regressions, we always did a scatter plot. So that's the first thing we need to worry about. And since it's a real life situation, all we're going to worry about is the first quadrant. Okay, there's 3 parts to a scatter plot. It was the scale, the labels, and your actual scatter plot. We can take care of the labels right away. We'll have our x-axis be the angle, and the y be the distance. Okay, from there, we need to go and plug in this information to get our scatter plot and our scale. So let's bring in the calculator. So if you remember, we're dealing with stats, so we're going to use the stat button, and we're going to edit the information that we need to plug in. Okay, I have it in there already. List 1 is your angles. List 2 is your distances. Okay. Now, in order to see the scatter plot, we need to turn the stat plot on. And again, you go second y equals, and we need to turn a plot on. So hit enter, turn 1 on. Okay, and then from there, we should be able to hit graph. Now, let me clear some stuff here. I got an equation in there. And then let's go ahead, let's hit graph now. All right, now, you're not going to see it right away because remember, we need to hit zoom stat. If you're using a TI-84, it was zoom 9. On the iPad, it is zoom 5. Okay, so there's our scatter plot. So from there, we just go and we plot our points. Again, it's just a little rough sketch. Okay, so now we can see from the scatter plot that is representing a quadratic, since it looks like a parabola. So from there, last thing we need is our window. Okay, that's going to give us our x min, x max, y min, y max. Okay, so if you're using the iPad, it's going to be 16.67 for that x min, 73.33 for the x max, y min 310.6, and y max 521.4. Again, if you're using the TI-84, you will get a little bit different values there. So, part B to this question then, which function better models the situation, linear and quadratic? Looking at the scatter plot, we can see that it looks like a parabola, therefore quadratic. Okay, so then write a regression equation for the choice from part B. So now here we're actually running the regression problem. Again, we go into that stats, and we actually want to run some calculations on the stats that were given. Okay, so we go over to calc. Before this, we did the linear regression, so number 3. Now we need to do a quadratic regression, so 4. And I believe it's the same number on the TI-84. So hit enter. We entered our data into list 1 and list 2. So we need to calculate. And we get y is equal to, our a value was negative 0.2614 x squared, okay, plus 22.5914x plus 23.0286. Okay, so there's our quadratic regression. Coefficient of determination, that's our r squared value, so 0.9993. Anything between 0.9 and 1, that was always a strong fit, so that's what this is. If it was between 0.8 and 0.9, that was a good fit. Anything below 0.8, that is where we had our weak fit. All right, so predict the distance traveled when the pumpkin is launched with an angle of 45 degrees. That's just saying we have an x value of 45 degrees. So from there, we plug 45 into our regression equation. Negative 0.2614 times 45 squared plus 22.5914 times 45 plus that 23.0286. Okay, so going to our calculator, I'm going to take this into its parts, so 45 squared times that negative 0.2614, okay, plus, and now put the next part in parentheses, 22.5914 times that 45, and I can finally add that 23.0286. So 504 we should have got 510. What do I got going on here? All right, either way, it should have been about 510, I believe it's 0.3. Okay, rounding to that nearest unit, we should have got 510 feet. Okay, so again, big thing there. You take that x value, plug it into your regression equation. All right, that was 5.8. Homework for this section is modeling practice. Okay, that's writing your equations in vertex form and intercept form. And then also you can do the regression practice as well. If you have questions, make sure you ask those. Otherwise, have a good day.